Hi, myself Puja, Assistant Professor of GKCM of GIS Group, Department of Electronics and Communication Engineering. Here you will find the details of my contact information, and I have developed a Facebook page where regular updates regarding this course are available time to time. Hi everyone. Here in this session, I will be going to explain basics of convolution code. So let us begin this session. Now see, when I talk about convolution code, that is what having block of encode digits generated by the encoder in time unit depends on not only block of k message digits within that time unit but also on the preceding m-1 blocks of message digits. Okay, so let us try to understand what is the meaning of that. So for that, I will take one basic example of convolution code. In that, if I take basic example, then let us have a shift register. So there are three blocks which is there in shift register. So first is having message bit M, second is having message bit M1, and third is having message bit M2. So this is the shift register which contains three blocks M, M1 and M2. Now see, in that here this is M. This M that is representing current message bit. So this is what current message bit. And these two bits that is representing state of convolution encoder. So these preceding two successive bits, it is previous to successive message bits which represents state of convolution code. So the first message bit which is M that is representing current message bit, and these two bits which contain M1 and M2 both are representing state of convolution code. Okay. Now I will explain all those things step by step. Now see how this shift register is working. Okay. First of all, if I say initially all bits are 0. So initially all message bits are 0. Now I say I give 1 bit message. So now I say I give 1 bit message with 1 over here. So the message bit 1 over here. So 1 will come here and this will be 0, 0. And if I send next bit, that is 0. So then this 1 bit will shift here and 0 will shift here, and this 0 which is over here that will get discarded. And after that state will become 0, 1, 0. Now, if I enter one bit over here, in that case, this bit will become 1. So this previous 0 that will shift over here, and this one will shift over here, and this 0 will get discarded. Now state will become 1 0 1. So first of all, initially all message bits are 0, and if I give one bit, so message bit 1 over here, so 1 will become here, and this will be 0 0. And if I send next bit, that is 0, then this one bit will shift here, and 0 will shift here, and this 0 which is over here, that will get discarded. And after that, the state will be 0 1 0. Now, if I enter one bit over here, so in that case, this bit will become 1, and this previous 0 that will shift over here, and this one will shift over here, and this 0 will get discarded. Now state will become 1 0 1. So ultimately, as you enter bits here, it will get shifted, and this first bit that is showing current message bit, and this 2 bit that is what previous message bits we have entered here. So this M is the current message bit, and these 2 bits M1 and M2 are the previous message bits which we have entered here, and which is showing state of the convolution code. So this M1 and M2 both are showing the state of the convolution code. Okay, so let us see how it will encode step by step. I will explain how things are happening inside. Okay, if I say I have one output which is I taking from here, and let us say this is x1, and second output that is x2, and output that is switching in between these two. Now, if I say it is x1, which is algebraic sum of all bits, then I need to add it to adder. So all bits that will be adding it with adder. And for this x2, if I say only this first bit and this last bit that is getting added, then x2 is algebraic sum of m and m2. Okay, so now here we need to modulo 2 sum. So when you represent this in terms of output, then output of first x1, that will be x1 equal to m modulo 2 sum m1 plus modulo 2 sum m2. Okay, so this one is a modulo 2 sum. So x1 will be m plus m1 plus m2. So it is algebraic sum of all. And output x2, that is what x2 equal to m modulo 2 sum m2, and this is modulo 2 sum. Okay, so if I say I have one output which is taking over here, and that is x1, and the second output which is x2, and x1 which is algebraic sum of all bits, then I need to add adder, so all bits that I will be adding it with adder, and for this x2, if I say only this first bit and this last bit that is getting added, then x2 is algebraic sum of m and m2. So x1 equal to m plus m1 plus m2, where this addition is modulo 2 sum, and x2 equal to m plus m2. So when you see the resultant output, so that is getting switched in between x1 and x2. So the resultant output which is getting switched between x1 and x2, and output string that one can obtain here. Okay. Okay, now what about states? As I have told that M1 and M2, that is justified state of this encoder. Basically, M1 and M2 both denotes the states of this convolution code. So, state of the encoder that is predefined. Like see, if I say I have M1 here and M2 over here and defining states. Okay. So, if M1 and M2 is 0, 0, so it is there in states A, and if M1 and M2 is 0, 1, so that is in state B, and if M1 and M2 is 1, 0, in that case it is in state C, and if M1 and M2 is 1, 1, it means both are 1, then it is in state D. Okay, so here when M1 and M2 is 0, 0, then it is in states A. When M1 and M2 both are 0, 1 respectively, then it is in state B. And when M1 and M2 is 1 and 0, in that case it is in state C. And when M1 and M2 both are 1, 1, then it is in state D. So, as you insert message bits here, then states will change. Okay. So, I will explain what is the importance of state and how we can have designing of convolution encoder. Okay. So, what is the importance of state and how we can have designing of convolution encoder? Okay, all those things we are deal with to discussions, and here in this session I will explain basic parameters only. So, what are these parameters which I have explained now? Okay. So let's see the parameters. So there is a shift register, and this is a 3-block shift register, one can see. Okay. So the first bit is representing current bit. and next 2 bit that is representing states of convolution code. So it is defined state here. So here output that is switching between x1 and x2, and x1 is the algebraic sum of all 3 bits and x2 is the algebraic sum of 2 bits m1 and m2. Sorry, m and m2. So this is the shift register. There are the 3 blocks. The first bit that is representing current bit and the next 2 bit that is representing state of convolution code, and it is predefined state. So here output that is switching between x1 and x2. x1 is the algebraic sum of all 3 bits, means m plus m1 plus m2. Okay, and x2 is the algebraic sum of 2 bits m and m2. So this is our output is there. So this is even modulo to output. Okay, and okay, now let us try to understand all those basic terms which is there in convolution encoder. Okay, so now when you see convolution encoder, there is k which define number of message bit. So this k, this small k, which define number of message bits. So now here one can see there is only one message bits. So k equal to 1 here, because the reason is only one message bit, that is what we are inserting here. So k equal to 1. Okay, now here n equal to number of encoded output bits. Okay, so one can see number of encoded output bits, that is what? That is x1 and x2, and x1 is the modular to sum of m and m1 and m2, and x2 is the m plus m2. Okay, so x1 and x2 both are the encoded output bits, or one can say modulo to sum of these bits. So ultimately here encoded output bits, that is 2. So n equal to 2. N defines the number of encoded output bits, which is 2 here. Okay, and the third is constraint length. Okay, now what is constraint length? Constraint length means it defines how many shift registers are there. Okay, so constraint length defines how many shift registers are there. So here there are 3 shift registers. So constraint length of this convolution encoder is 3, because there are 3 shift registers. Okay, so constraint length, that is based on number of shift register. here constraint length capital K, that is equal to 3, and that is based on number of shift registers which we are using. Okay, so these are the basics that you should know. Okay, as I have told you, output is getting switched between x1 and x2. So output stream, that will be x1, x2, x1, x2, x1, x2 over here. Okay, so that is here, that is happen over here. Okay, because the output is switching between x1 and x2. So output stream x1, x2, x1, x2 like this. Okay, so the output stream that is getting obtained as per x1, x2, x1, x2 like this. And okay, when you want to calculate the code rate, okay, what is the code rate? Code rate is denoted by R, which is K by N. So code rate R equal to K by N, where K, that is number of message bits, and N, that is output encoded bits, which I have already discussed. So for this particular example, K, that is what number of message bits, which is equal to 1. K is equal to 1, and N is output encoded bits, and that is 2, because there are two outputs, x1 and x2. So code rate of this convolution encoder example, that is 1 by 2, because R equal to K by N, K equal to 1 and N equal to 2, which I have already told. So R will be 1 by 2. Okay, and as I have told you, constraint length K, that is based on number of shift registers. So in short, we can say number of shift registers, that is equals to constraint length. So the code dimension, that is represented by N comma K. N is encoded output bits, and N is output encoded bits, and K, that is number of message bits. So this example that explain you this convolution encoder, that is 2, 1, where 2 equal to number of output bits and 1 equal to number of input bits. Okay, so when you see this dimension, it is what we are recalculating, or one can say this is calibrating with respect to time. So at a time you will be having this. So with respect to time, this will change. So this N and K value will be fixed, but data of N and data of K, that will get changed with respect to time. Okay, and as per that you will be finding output x1 and x2 is getting changed. Okay, so these are the basics which is regarding convolution codes, and I hope that you have understood this session, and thank you so much for watching this video.